Some fun stuff, and we'll let him do that in a second. But first of all, a couple of quick announcements. The spring cyber defense competition is coming up pretty soon in the end of March, on March 26th. So sign up for that is at signup.isg.org. Go ahead and do that anytime. Also regarding that, tonight at 6:15, which is right after this meeting, in this room, we'll have a kickoff meeting where we'll discuss the scenario and help you find teams if you don't have teams for the competition yet, if you're doing that. Alternatively, at the same time, there's a beginner's night on Matt's presentation, basically, so more hands-on, playing on the demo and stuff like that. So, hand it off to Matt. So,
CDC kickoff right after.
I just mentioned that. I did mention that, right?
Someone was paying attention.
Yeah, no, you mentioned that.
All right.
So yeah, like the slide says, so this is like you guys are allowed to like screw around and do whatever you want. Yeah, please just don't blow up anything in the demos folder. You'll notice if you go back to the root that there's also Utilidae, which is like a vulnerable web app thing. So there's tons of ways to pwn the VM that I've got running at this IP. So with that, so the name of this talk is Scripting Web Attacks with the Python Request Library, or the other title, which is How Your Flags Got Stolen at 8:05 a.m. in the CDCs. So, because it can happen that fast. Okay, so so this is something that I really like. I'm Matt. I've been red teaming for a while now, and I always enjoy red teaming, and especially the CDCs where there's a lot of web apps involved, and particularly even more in detail than that, I like it when they're open source, because then I can go and look at the source code, and I can make scripts like we're going to talk about today. And walk in at 8 a.m. of the CDC, and if you haven't fixed your vulns, you're going to get pwned. You're going to get pwned right away. So this time I'm making the web app for the CDC, so you don't have me to contend with, but you got other guys like Tom Pohl who will do that to you. So to start off, before we start talking about attacking websites, we need to know like what the heck is the web. So. Once upon a time, there's some RFC. Some guys decided that, hey, we need ways to get files from one computer to the other. So the HTTP protocol was born. So this is an application layer protocol. If you know what that is, it just means that it's a really high-level protocol. It doesn't care about low-level stuff like Ethernet or something like that. It's talking at a pretty high, easy-to-understand level of kind of similar to, hey, I want that file, and then here's that file. That's what HTTP is all about. It's all about, sending requests and getting responses for files. And it's all text-based, as the name implies. So what that means is that, you'll see what that means. So this is an example of like the most basic request in the world. So I'm on the internet and I want to get a file. I want to get a home page, or in this case, I want to get the first demo exercise. So the request that your web browser will make when you put the URL, the IP address / the name into your web browser, it will make a web request that looks similar to this. It'll have some other junk in it too, and we'll talk about that in a little bit. But basically, it's going to send a GET request, which means give me the data. And then it's going to specify what file on the server I want to get. And it's going to say HTTP, the protocol version, which we don't really care about. And then it's going to say, what is the host? Where is this file hosted? And as you can see, that's basically what happened. This is basically the content of a URL in your web browser. So, and then you'll see I've got like 2 lines here. That's because, like I said, it's a text-based protocol. So when the server's listening to your request, it needs to know when you're done making a request. And so the way they do it in HTTP is if there are basically two empty lines, or a carriage return and a line feed, if you want to get technical. Basically, if there's 2 empty lines at the end of the request, then it knows, okay, this is a complete request, and now I can process it and give you a response. So that is the most basic way to get data on your internet. Your web browser is doing it all the time in the background without you knowing it. The next kind of request that we really care about is a post. There are some other oddball requests, but most servers nowadays will just refuse to accept those request methods. So this is a post. So a post is similar to a GET. It's still a request. I'm still kind of asking for data, but I can also send data to the server with a post. So what we see here is an example, and this is a really common use for a post, and that's on a login forum, or any kind of form where you fill in data and you hit submit, and you send that data over the web. It's going to look something like this. So instead of get, we're going to have post up here. Again, we're saying what file do I want to send the data to. We've got our host header here, and then we've got one empty line, and then we've got the data. So this is actually the payload that I want to send to the target. And you see that it's separated, so you have the name of the variable, and then an equal sign, and the value. And then you can send multiple chunks of data in a name value format by separating them with an ampersand. And then again, at the end, we say, 2 lines, now my request is done. And there's one other thing that you need to know about HTTP, and that's the headers. Now, in those other 2 requests, we already saw one header, and that's the host one. That's really the only header that's required. You can get away with that really basic GET request that we saw. But often your web browser is going to send a bunch of other stuff. So here we see another header here, and the headers you can notice it's like the name of the header separated by a colon and then the value. So here we're sending a user agent. So this is what your web browser does. It says, hey, I'm Firefox running on Windows, or in this case I'm Firefox running on a 64-bit version of Linux. So that's useful because then the website, maybe if it says, hey, I'm broken IE, then it sends you a web page because it knows that IE is broken, right? So that's something that can be helpful to a web server to serve up content just for your device, right? If it says iPad, well, now I know that I'm going to send you my mobile version of my site instead of the desktop version. And then, lastly, we have a cookie. Good old cookie. So a cookie is basically a piece of data that the web server has given me, and then every request I make, I'm going to send it back that cookie. And that's used for a lot of different things. Usually it's used for session management. So when I log into Facebook or something like that, I send it my username and password. It gives me back a cookie, and then every time I go to that website, I send it back that cookie, and then it's like, oh yeah, I gave you that cookie, so you're good. So because you don't want to keep entering your username and password in all day long. So those are, and there's tons of other headers, but those are the good ones. So now we're going to get into, okay, so how can we do some of this stuff in an automated fashion, right? So one of the big things, to take a step back, is when I'm red teaming, there's lots of fancy tools out there and stuff like that, but my biggest tool, honestly, is my web browser. I'm just going to poke around your site with my web browser and some of the developer tools until I find interesting stuff. Once I find those vulnerabilities, though, then I'm probably going to turn to something like Python that's going to allow me to script any kind of attacks that I find, so I can hit you really fast, and I can hit a lot of different teams at the same time. So that's where it gets fun. So yeah, the Python request library, it just enables you to, it's an API, it's a library that lets you talk the HTTP protocol. It's on every operating system, so some of the uses of it, so again, what we're talking about here, it's about scripting web attacks. The other thing I've used it for, this little fun project, scraping websites. So if you want to just automatically go out and pull data off websites, maybe to track down some rogue hacker who happens to be sitting in the audience. So this is a little project I wrote that will take in a list of emails, and it'll go out to the IASG directory, also known as StalkerNet, and it will pull back address information from every email that you pipe into it. So, and it does it in 21 lines of code. You can go look at that. Have some fun. Okay, so it's demo time. So yeah, and if you guys want to walk along with me, again, we're on Starbucks Wi-Fi, and at this IP address /demo, and then we're gonna go into this first demo. So I tried to keep this super simple, so we can understand the kind of the essence of what Python requests is going to allow us to do here. So our first demo, it comes up and it says access denied. You're not using IE8, right? So again, this comes back to we're probably going to send it one of those user agent, right? That user agent string for IE. Because again, your web browser self-identifies, and you can tell your web browser to lie and be whatever web browser you want. So that's what we're going to do here. So first we'll do this in our web browser, and then we'll kind of do it in Python requests. So I got this little add-on called the user agent switcher, and I'm just going to go tell it that I'm IE, and then I'm going to send a request, and then it changes. So now I've been granted access. So that's all that does. I had to whip these up pretty quick. So now what we're going to do though, go over here, is we're going to write a Python request program to do that same thing, to masquerade as an IE8 web browser and then make that request and then get the access granted response. So I'm going to open up a Python file. So first thing we're going to do is we're going to import requests. And then we need to store the URL in a string. And so that was .4/. Yeah. Okay, so there's our URL, and then we're going to call the requests library to help us out. So we're going to be request.get, so we're obviously going to be using the get method at the URL, and then we're going to just print the response that we get from that request. So obviously this is going to fail because we're not doing anything for our user agent, but I'm just going to run that real quick and we'll see the output of that. So it comes back, it prints out just what our web browser did, access denied. So again, in like 3 lines of code, you can do a really basic request to a web server, but now we want to do some interesting stuff. So now we're going to create the user agent string, and then I'm going to go back, and so if you didn't have this add-on, you could just Google, IE8 user agent string, and you could find this pretty easily. So I'm going to copy that guy, throw that in there, and then we're going to create like a header dictionary. So if you're not familiar with the dictionary like object in Python, it's just it's an associative array. So it's pretty nice. So all I'm going to do is say user agent, which is the name of the header, and then I'm going to so that's the key, and then the value is going to be this string that we just created, and then we just go to our requests, and then we add the headers option, and then we throw an H in there. So now run the same thing, we get access granted. So now we have scripted a way to fake it, to pretend to be the web browser, and we can make all kinds of requests as if we were IE8. So let's go back. What do we learn from this? So we learned that you should never, ever like write something on the server side that relies on a browser telling the truth about itself, because that's something that the client side controls, not the server, and that means that it's going to be a hacker in the hacker's hands, in your adversary's hands, to tell you whatever in that string. So from here on out, yeah, a bunch of demos. Do interrupt me if you have any questions about what this is. So now we're just gonna move on to demo 2, and we're gonna do some more scripting. So this one comes up, and it says you're not the admin. No cookies for you. So it's implying we got to do something with cookies now. So and now I'm gonna actually take a look at something. So again, like I said, my biggest tool is a web browser. Now there are other really fancy tools out there, like man-in-the-middle proxy, really awesome one. Burp Suite, really cool too, that allows you to really analyze these HTTP requests that's coming from your computer and going out to a target. But I just want to keep it simple and show you that it's like, at the end of the day, you can do a lot with a web browser and some Python code. So I'm just going to go hit Inspect Element, which is really just going to bring up the developer tools, and then go to the Network tab. I'm using Firefox. Chrome has a really similar layout. You might have to find some of the specifics yourself. So I'm going to reload the page. And then now I see this GET request here. And I can click on that. And then what I like to do is go to raw headers. So here we go. We see the actual headers that in my request. And then we also get to see the response headers. So the response headers, we're going to talk about that at the beginning. Those are headers that the server sends back to you. So there's often a lot of useful information in there as well. So for example, right here, server Apache, right? So and Debian. So this, if you ever wondered like how somebody on the red team can like really easily figure out like what OS you're running and stuff like that, it's because web servers like Apache really like to announce like, hey, this is my operating system and this is what version of Apache I'm running. So that's just another useful tidbit. But what we're interested in is this set cookie line right here. So it's setting a cookie is admin and it's setting it to 0. So what do you think we want to do to that? Set it to 1. All right. So in my web browser to do that, there might be a way to do it with Firefox tools, but there's a nifty thing like another add-on cookie manager. And so I can go in here. Oh, I've got one from the other end too. So I'm just going to go into the isAdmin cookie, set it to 1, and then we're going to reload this page, and then bam, you're the admin. So now we're going to figure out how to do that same exploit in Python. So I'm going to open up, actually, I'm just going to go off this one. Alright, so don't need this, don't need that header anymore. So you could, in requests, so in that headers field, you could manually set the cookie, in the same way that we did with that user agent, but it's actually got a built-in thing for cookie management just because you use cookies so much with these libraries. So again, it's going to be in a dictionary, and we're going to set, isAdmin. We're going to set it to 1.
Misspelled isAdmin.
Oh, thank you. Yeah, that wouldn't work. Okay, and then we're going to say cookies equals C. So we're just, assigning to the cookies like object in the request our little dictionary here. And then, oh, crap. We need to change this to demo 2. And bam, you're the admin. So again, this just shows us that in requests, we can do the same things we can do in our web browser. That gives us a lot of power to be able to do all kinds of fun things, which we will see. We'll kind of see a little more realistic way of how we can really pwn things in the next demo. But really quickly, I like demos, I don't like slides. But anyway, so our lesson learned here was, again, in kind of a similar way as the user agent, one, don't trust user input, because the cookie is just another thing that you can change and send over the wire to the server. So what cookies really should be, at the end of the day, they should be a random string assigned to you by the server, and it shouldn't derive the meaning from the content of that cookie. It should be doing a lookup on its side. So what should really be happening is, if I log into like Google or whatever, it should give me a random number, really big random number, and then I submit that back as the cookie, and then it's going to have a big table of, username Matt has the cookie big long random string, and it should, or is admin is big long string. And it should do that interpreting on the server side, not letting me obviously understand the functionality of the app by making it so obvious as like is admin. And most of the times it's not that obvious, but you shouldn't ever have something be that clear cut in a cookie. So that's that one. So now, if my slides will move on. Wow, okay, my things failed there. Anyway, we're going to move on to the next demo. Okay, so has anybody been following along with the demos, by the way?
Oh, yeah.
Anyone?
I had shell, but then your web server was. I had shell for like 20 minutes.
All right. So yeah. So the people that haven't. So demos 3 and 4 here are kind of linked. So you can't get into demo 4 until you've passed demo 3. So this one on the web browser, we're going to see how easy this is, and then we're going to see in Python requests, we're going to notice something that is going to cause problems. So this one, it's like, okay, you log in, admin, right? Okay, and it's like success. So how is this a challenge? So some things that you do in a web browser, it's doing things in the background for you that you don't understand, and then when you go to script it, it's like, what? What's going on? It's not working. So again, we're going to let's go look at this request first and see what's happening. Okay, so, yeah, it's right there. So if we look at, so we're not going to actually see the data in the raw headers, but if we go into parameters, so kind of like in that post request that I showed in the first slides, the two parameters here are username and then the values admin, password admin. So now we'll write the program that'll send that data to the server, but then we're gonna find out that it's not that easy when we're scripting. All right, don't need cookies. Okay, so the first thing we're going to do, okay, so, yeah, and if we notice right here, yeah, again, it's a post request, demo 3, username, password. So that's what we're going to replicate in here. So the way you do that is, again, big shock, it's a dictionary. The request library really likes them. So for the admin field, we're going to set it, or sorry, the username field gets set to admin, and the password field was set to admin. Change it to go to demo 3, sending a post. There we go. Oh yeah, and then we do data text. Yeah, data equals, and then our object. So here, unlike the web browser, we got this error message, CSRF token failed. So, if anybody had ever heard of CSRF before? Who can tell me what CSRF does, or what this means that I'm getting a CSRF error? Anybody? Okay, so CSRF is meant to, well, okay, it's meant to do a couple of things actually. Its intent is to make sure that you can't trick somebody via a link or via some piece of JavaScript. So if I can trick some user to come to my website and I've got some JavaScript that forces them to make a request to this thing, I don't want them to I don't want them to be able to be tricked into that. So what a CSRF token is it's a cookie. It's a cookie that you set and you say you have to make a GET request first, right? So if you think about it, when we're using our web browser, what do we do first before we make a post? We make a GET, right? So we get the page, and then we see the fields here, and also in this GET request, what we'll find is that in the headers, it sets this cookie CSRF. So the login will not be valid unless I have a CSRF token in my post. So it helps prevent this weird form of attack called cross-site request forgery. But the other thing that it makes really annoying for people like me is when you're trying to brute force or do some kind of scripting against a login. It gets really annoying if something like this is in your way. So what we have to do is we have to make a GET request first, grab that cookie, and then put it into our post request. So, but the good thing is that's something that request is pretty good at. So, before this, so first we're going to make a GET request, and a GET request doesn't need any data. And then what we're going to do is we're going to grab a cookie from this response. So you can do that just like that, I think. There might be an S. Yeah. Okay. So basically this R, so yeah, the R there is the response from the server. It's like the object or whatever. And then we can grab any cookies out of there, save them to a variable, and then kind of like we did before here, we can say cookies equals C. So now we're making that GET request first, just like I would in my web browser, grabbing that CSRF token, and we're going to throw it into the post request. And we should see this. Boom. So you see a lot of HTML, but basically you got the login success message. So now that means we can move on to the fourth demo, fourth challenge. So yeah, when you do this, what? Why is it not giving me my link? Did you break something?
Is it the CSRF? Maybe.
Well, anyway, I can get to demo 4, so
Yeah,
not a problem.
well, one thing I've noticed is that, like, when I leave a session open for a while, it stops, like, it just doesn't That might be Firefox's fault. Like, every time I shell that, I think Firefox was opening all the
Okay. It's really not a problem. It was just supposed to meant to like there. Okay, it worked that time. It's supposed to just give me a link anyway.
I think
It was really pointless, but I was like, why was that not working?
Your CSR tokens file is, I believe, an ASCII right
Is what?
It's
So that's what's going on. All right. So what we're gonna do here? Okay. So here we go. We're on demo 4. Now we're gonna get to have some fun and actually like pwn the box. So what we have here is we've got a nice little handy ping tool, so we can ping the router with it, submit, and it gives us back the response, right? Well, when you don't write one of these functions correctly, you can do all sorts of fun things. So if we actually look at the code, so this is actually where it'd be fun to look at the code. So let's go here and look at the demo 4 code and see what this PHP code looks like. You don't even have to understand PHP to understand what the heck is going wrong here. Okay, so basically, I grab in that IP variable that I send to the server via the post request, and then I create this string called command, where I just append onto the end of that command whatever the user put in, right? So this is all user input, this is user input, this is user input. Now this command becomes possibly tainted with user input. And then I just run shell exec on this, which is just like if you were in a Linux command prompt, right, or a command shell, right, and you just type this whole thing in there and hit enter. That's exactly what this this PHP code is doing for you on the back end. So I can do fun things like this and list all the files in the directory, or I want to see what he did. What? Which file? Which file did you do? The session? Okay. Well, it obviously doesn't show up right on there, so that's a middle finger, is what you're saying?
Well, it is if you drew it as plain text.
Okay. Oh, it's because
It's rendering as HTML.
it's because HTML doesn't respect new lines inside the text. So, oh my god, wow.
Oh yeah, that's
That's pretty easy to understand, even if the HTML isn't rendering things properly. All right. So let's find something else. Okay, so we can do fun things with this. So now the fun thing, and this is what's great, is when I'm red teaming and I have something like this. Especially again when I get source code before, it means I can write up one of these scripts and come again, at like 8 in the morning and press go and like auto pwn people. So we're gonna extend our little demo 3 script to do that. So now we need to make another post request, this time to a different URL. Let's call that URL 2. This time it's on the demo 4 one. Change this to URL 2. The data we also need to change. This IP. And then I'm just going to make just to make it easier. Okay, so let's just make it LS stuff first. So we're going to set the value of this to commands, have it get submitted. Again, with it, we need that cookie, URL 2, that looks good. So there we go. So yeah, again, it's hard to see because of the HTML, but I'm listing the directories on that server. So I am executing code on that server. So now, it's not too hard to turn this into something that gets me a reverse shell. So now we can change this command to something a little bit funner. So I'm going to netcat send bin bash to
Top 5.
oh thanks.
It's on the bottom of your screen.
Oh yeah, I forgot I have that handy info right there. Alright, let's just send it to that port, and then, so we're going to run netcat over here. So netcat, so what I'm doing on this netcat session is I'm going to basically listen for a connection. This is not at the HTTP level, now we're down a layer at the TCP level. I'm basically listening for a connection, and then what I'm going to tell the server to do, the web server that I'm attacking, I'm going to say, hey you, send bin bash over the network to my machine, the attacker's machine. So that's what this is going to do right here, this netcat command. It's going to say, execute bin bash, send it to this guy at this port. So again, so over here we're listening. And then we execute, and then I have a connection. So now I can just execute commands just like now I'm only www data. I'm not dumb enough to let my server run. I know you're probably sad that it's not running as root.
There are only like 4 files in the file system I can write to.
Why is there GCC either?
And you don't have GDB, so I can't GDB attach that. It's gonna do that.
Yeah, I'm sorry. Didn't make it as vulnerable as you wanted. Yes.
What are the Netcat flags and VLP?
Oh, number. What's N? Crap. I don't even know.
I don't know.
Resolve names to numbers.
What's that?
Resolve names to numbers?
Revolves names and numbers.
Well,
Oh,
Does it apply here? I don't know.
maybe.
Actually,
P is verbose, L is listen, P is port. I don't know. I don't know N.
Yeah, N is resolved to IPs instead of using host names. But
You might even have a different netcat.
Yeah, there's also different versions of Netcat. Like I was trying this on my Mac and it was like retarded because it's like the BSD version of it.
But this
So-
relies on the Netcat being on the remote host as well.
Yeah, exactly. So I'm using two different netcats. I'm using one on my Arch box, on the attacker box, and based on the different commands. So this one here, I'm telling it to listen, but the other one, it's not. So netcat in this thing right here, netcat right here, this command, it's basically like, it's almost like telnet in the sense of make a connection to this IP in this port, except it's going to send it bin bash. It's going to send a terminal so that, so nice, we're going to let the other person on the other side of that connection type things. So that is how yeah, I guess we on the red team go about looking at web stuff, you know, so it's, the first step is, yeah, looking at things in the web browser, maybe using a fancier tool, prototyping the attack in the web browser, and then you take it to the next step where you make some fun scripts like this, and then you can go in and click a button and have fun things happen. So that's all I got. Anybody, any questions about anything?
So -C4 in the MC.
-C. I think that's just the program to run. So I don't know like the specific meaning of -C, like what it stands for,
Run a
but
shell command after.
what's that?
Run a shell command after the connection completes.
Oh, so it wait. Oh, right, because it waits until the connection and then runs. Yeah, so it's basically specifying bin bash. So that's a binary program that it runs. Yeah, but no, that makes sense. It's got to wait until after the connection is made.
What version of Python are you using?
I'm using Python 2. So I don't.
2.9 or 2.7?
2.7.
Okay. Well,
I think there's requests libraries
yeah,
for.
URL lib 2.
It might be
request.
different. Yeah,
Okay.
it might be different if you're using, especially if you're using Python 3.
I'm using 2.7, so
Okay, you should be good.
URL
Or
lib
what
and
OS?
Requests
What
are two different things, I believe.
Yeah,
Yeah, those are two different libraries.
Oh, yeah, so-
Two different APIs.
so like not 2, but just the normal.
So okay, so Python or requests is a Python library that's not like in Python itself. You have to install that separately.
Okay.
So if you're, and we can go over this at beginner's night too, but if I go all the way up, dang it.
Basically, they're different libraries.
So like yeah, what OS are you on?
Windows 10.
Okay, I don't know how to install Python packages on Windows, but
you do this command line and you set environment variables and just use pip and install the files.
oh, is it pip? Oh, great. Okay. So yeah, no, that's why like the best way to do it is if you get this program pip. Gosh, I can't even use my mouse there. Yeah, if you get pip, then you can pip install whatever Python packages you want. That's like the best way to do that stuff.
Which request is on Python 3?
yes.
Yeah, it's on Python 3 also. I just don't like Python 3.
Only Python.
I don't know. It's more like, it's not for like a logical reason. It's just because I know to, and then when I use 3, things break, so I get mad at it.
Networks don't break.
Yeah. All right. Any other questions? Thoughts?
Do you have a shell?
Oh, this
Or you're not using Netcat? Because I killed everyone's Netcat shells.
no requests, yeah.
I still got console
Yeah, I think it's all up.
Yeah, you get console.
though. Where are you?
It's TTY.
Requests.
What?
I'm not using Netcat shell.
Oh wait, hang on. I know what you're doing. You're grabbing a TTY with Python, aren't you?
Yeah, I'm using Python, and I got full TTY on this thing. I can use bin.
Yeah. All right. That's all I got.
I need to get a cheat sheet of reverse shells. Reverse shell cheat sheet. You have
Oh well. I basically copied it, but on my GitHub, yeah, I've got that. And plus some other ones. There's some
Do
really
you have the Gawk one?
The what?
The Gawk one.
Gog, no.
Oh,
Oh,
Andy
yeah.
told me about it over the